Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about autocorrelation function of y of t, output y of t, and what is the average power in y of t. Example. A random process x of t is applied to a network with impulse response h of t is u of t into e power minus bt, where b is greater than 0 is a constant. The cross correlation function of x of t with the output y of t is known to have the same form. Rxy of tau is equal u of tau into e power minus b tau. First bit, find the autocorrelation function of the output y of t, and the second bit, what is the average power in y of t. So coming to the solution, given that the impulse response h of t is equal t e power minus bt u of t. So taking Fourier transform on both sides of the impulse response, Fourier transform of h of t is equal Fourier transform of t e power minus bt u of t. So Fourier transform of h of t is h of omega. Using the standard expression, Fourier transform of t e power minus bt u of t is 1 by b plus j omega whole square. So given that the cross correlation function of x of t and y of t is Rxy of tau is equal tau into e power minus b tau u of tau. So taking Fourier transform on both sides of this equation, Fourier transform of Rxy of tau is equal Fourier transform of tau into e power minus b tau u of tau. So the Fourier transform of Rxy of tau is cross power spectral density of x of t and y of t, that is Sxy of omega, and the Fourier transform of tau e power minus b tau u of tau is 1 by b plus j omega whole square. So we know that the cross power spectral density of x of t and y of t is Sxy of omega is equal h of omega into Sxx of omega. So now here Sxy of omega value is 1 by b plus j omega square. Substitute that value into here, and system function expression is already calculated. Substitute that value into here. So from this equation, on both sides 1 by b plus j omega whole square is cancelled. We get Sxx of omega is equal to 1. Sxx of omega is the power spectral density of the x of t. We know that the power spectral density of output y of t is Syy of omega is equal magnitude of h of omega whole square into Sxx of omega. So h of omega value is already calculated. Magnitude of h of omega whole square value is 1 by b square plus omega square whole square into Sxx of omega value is 1. So therefore Syy of omega is equal 1 by b square plus omega square whole square.